Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu wa ala alihi washabihi ajma'in. Okay, so for today, in code BQS 652, we will continue where we left off. Previously, we have covered a bit on the introduction of coastal protection. So today, we will move on to coastal management and coastal protection technique, namely the hard engineering and soft engineering works of coastal protection. Right. So for our first slide today, involve the coastal management. So in coastal defense, there are five generic strategies or five approaches that can be implemented. First of all, is obviously inaction, meaning that we do not do anything to that part of the coast to protect it from the assault of the waves, okay, from the sea. Secondly, is to retreat or to realign, meaning that we will use engineering solutions and identify new line of defense where to construct new defenses, meaning that we would move a bit inland and start a new coastal protection in that location. Third is hold the line, meaning that the defenses, okay, where the seawall are exactly where they are along the coastlines, and we do not move them, okay, but they would be in their place. Fourth, to move seawards, meaning that we construct new sea defenses towards the sea, meaning that we are building our coastal defenses into the sea, towards the sea. And fifthly, the limited intervention. There are just some minor adjustments so that the flood that happens can be coped by raising coastal land and buildings vertically. So to see all that in a graphic form, okay, you can see here. First one is, of course, the inaction. We do nothing. Okay, we let the sea to reclaim the land as natural process. Okay, the second one, the managed realignment, meaning that we move all the man-made structures inland, okay, and set up a new sea or coastal defenses. Okay. Third is to hold the line, meaning that we will build a sea protection where the structure is presently located as the sea continues to rise. Fourth is to move seawards, meaning that we will build our sea protection into the sea, towards the sea. So by doing that, we are having a bit more space. And lastly, by limited intervention, usually this involves a bit of soft engineering aspects so that the floods that come in from the waves are more bearable, okay, manageable. Next, the coastal protection techniques. There are two types, hard engineering and soft engineering. Most that we'll be covering today are the hard engineering. Structure or hard engineering techniques. It involves the use of permanent concrete and rock constructions to fix the coastline and protect the assets locate behind. So we have predetermined the coastline is where we place this concrete and rock construction. This includes seawall, groins, detached breakwaters. It's built to protect expensive properties and infrastructure. This is when the infrastructure which are behind the hard engineering features, they are immovable. They are very expensive. Okay, so we must take the approach of what was it earlier, to hold the line. Yeah. So this is when we build these hard engineering structures. So you can see here that the sea has begun to reclaim, okay, the coast, and there is an expensive structure here, okay, which are located near the coastline. So in order to save this structure, hard engineering coastal protection technique needs to be implemented. Okay? Or in a couple of weeks or a couple of months' time, this building will be claimed by the sea. Can't say the same for this house. Obviously, it has been, the soil underneath the house has been reclaimed by the sea. So this affects the house itself. Now, this situation is made worse by if there is rising tide, plus if there is very harsh weather, like hurricane season, things like that. So this will make the situation a lot worse. Okay, so this is another example. So the sea does not only reclaim a very small part of the beach or the land. Okay, it can also claim lands which are very high, or what you call normally, which is beyond the reach of the waves. Okay? So the waves can go into the between the soil particles and make the bottom part of the cliff, okay, the soil there, waterlogged with a lot of seawater. It will make that part of the cliff very weak, okay, the bottom part, and the cliff will just slide downwards. Yeah. And then we have another method of soft engineering, namely sand or beach nourishment, constructed through natural process and relying on natural elements such as sand dune vegetation to prevent erosive force from reaching the backshore. So in this method, we do not rely on the use of concrete or rocks. Temporary and needing regular replenishment appear to be more acceptable and go some way to restore the natural dynamism of the shoreline. So this is more of a naturalistic approach to protect the coast. Okay? So they just replenish the beach that have been eroded, okay, with new materials. They also plant new vegetation. Another thing which they can include there is to promote the growth of coral reefs, okay, in the show. You can see here that the sand has been eroded into the sea. Usually, this would happen because of very strong waves from very heavy rains, or tidal waves from hurricanes, tornadoes. But it can also be the result of man made activities such as they are building something near the edge of the coast. And because they are building something at that location, it will affect other locations, meaning that other locations near the part where they are building these things will have uh, a lot more erosion, okay, due to the changes made to the feature of the coastline. Okay, so you are building something at this part of the beach, but the effect due to waves can be felt at other places along the beach. Okay, so this is something that needs to be considered. Okay, here you can see it's typical sometimes for hurricanes to completely wipe off the top layer of sand of beaches, whereas uh, sometimes the authority have to bring in and pump new layers of sand, okay, to replace that sand that has been eroded. Okay, so you can see here that the erosion is quite bad around here. So now we move on to the hard engineering. The types of coastal protection structures. I believe the first five is hard engineering. The last one is like soft. First of all, the sea wall. It's a form of coastal defense constructed where the sea and associated coastal processes impact directly upon the landform of the coast. So this is where the sea, which is nearby, let's say where people are living, they are very close. So any extreme weather will trigger the sea to negatively impact the population. So meaning that there are no more space to be given to the sea. So this is where you have to build a seawall. So normally to protect areas of human habitation, conservation, and leisure activities. Okay, so you do not have space to be given. Classified as hard engineering, structure used to provide protection and lessen coastal erosion. However, a range of environmental problems and issues may arise. For example, disrupting sediment movement and transport patterns. So even though this seawall can seem to be a good solution, but it can bring a lot of negative impact. You are having a very heavy structure being built across across the beach. This will obviously affect the waves, okay, and also affect the erosion in that particular area. And this will also block the, let's say, the movement of animals, okay, to and from the beach, okay, when you have this kind of obstruction being built. Okay, so there is an example. Here is the seawall. Some other examples, okay, you can see here. That's a seawall. Obviously, it will be very difficult for animals to go through the seawall. Okay, some other more extreme example of seawall. These are a bit more higher, a lot steeper. And the seawall does not only consist of the wall itself, there are some sort of interlocking blocks or rocks in front of the seawall to break up the waves into smaller waves before it hits the seawall. So this is to protect the seawall from uh, the big waves, okay, that can damage the seawall itself. So in terms of material, normally they are reinforced concrete, which has been added some admixture so that uh, it will last in the environment of salty seawater. Can use huge boulders, steel seawall, but this would require a lot of maintenance, and gabions. Some other smaller size seawalls, you can use vinyl wood, aluminium, fiberglass, composite, or even sandbags. Okay? But these are more towards a temporary measure. So by having the seawall, we are basically reflecting the energy from the wave. We are sending it back to the sea. So this reduces the energy of the erosion. And you can see that even before the waves come to the seawall, they are being broken up into smaller waves, okay, by the rocks, the boulders. So there are two specific weaknesses of seawall. The reflection induced by the wall may result in the scour and subsequent lowering of sand level in the fronting beach. So this is where before the seawall is being built, the design needs to be tested in a what you call a hydrographic facility to check that whether installing the seawall would provide a better condition for the uh, for the environment, or it will just make it a lot worse. If the full brunt of the energy from the waves are being reflected back at 100% to the sea, this may cause the soil in front of the seawall to be more eroded. Okay? Because that part of the soil is like being washed away twice. Okay? First by the incoming waves, and then second by the outgoing waves. Okay? At the same magnitude of energy. So this will cause the front of the seawall to be eroded a lot more. And sooner or later, it can cause the seawall to topple over. Secondly, seawall may accelerate erosion of the adjacent unprotected coastal areas because they affect the littoral drift process. So sometimes by installing a seawall in a certain part of the beach, the other part of the beach which have not been installed any seawall, the erosion in that area will become a lot worse. Yeah? So you protect one part of the shore, but the other part of the shore, the erosion is a lot worse. Okay? So again, this kind of hydro pressure needs to be tested first at a high-tech hydro lab before the seawall can be built. Okay? You cannot just simply decided one day to build a wall in that area. Okay? Whereas you may damage other parts of the area, or your seawall will come, crumbling down in a matter of years. Okay? In terms of type, we have three types: the vertical, the curved, and curve or step and mount. So this is the vertical seawall. You can see it goes almost straight up. It's like a retaining wall. Other types, so this is the curved concrete seawall. So that when the wave comes in, the curvature of the wall will cause the wave to go upwards and goes back down. Okay? To be like deflected back to the sea. So this is the step and curved concrete seawall. This is a lot safer for people or animals that are around that area. The one that we usually see is the rubble mound seawall, where there is a concrete core and then it's being covered by a lot of large size boulders. Okay, because the holes in between the boulders will help to absorb the energy of the incoming waves. Okay, it's not like this curved seawall ni. Kan? Curved seawall ni is like it's reflecting back the energy to the sea. Okay, at almost the same magnitude. But by having this rubble mount seawall, kita tahu lah kan batu-batu ni ada ruang-ruang kosong. Okay, di antara batu ni, those voids will help to absorb the seawater and also the waves. So when the waves goes back to the sea, the power that the wave carried has been reduced. And this is Gabion seawall, more towards temporary seawall. So first of all, the vertical seawall built in particular exposed situation, they reflect the energy waves. So there are no holes or whatever in that particular vertical seawall. So the wave will hit the wall and be reflected back. Some cases, parts are placed in front of the wall to lessen the wave energy. So sometimes the energy that hits the wall can be quite severe. So they put something in front of the vertical wall to break up the waves into smaller waves. So that is what being done by being done naturally by the coral reef. Okay? Batu karang yang terdapat dalam laut tu is very hard material, very hard and living material. So one of its purpose is to break up the waves inside the water. Wave tu belum sempat keluar lagi. Yeah, the coral reef will break up the waves inside the water before the wave travels towards the shore. Okay? But if that area is polluted, there is no more coral reefs, so the waves from the ocean can just travel straight to the shoreline. So that is when problems starts to happen, erosion and things like that. So advantages, I mean, it's just practically a wall, so it's very simple to be built. It deflects the wave energy away from the coast. Okay? I mean, behind the wall, there is a lot of material that will stop the wall from being crumbled. Whose rubble can absorb the energy. The advantages. Particularly can be undercut by high wave energy environment for a long period of time. So this design, if not being built properly, will not last that long. So to overcome that, so instead of receiving the energy directly and reflecting it back to the sea, we use a curved seawall, which it will not receive. It will just deflect. Okay, deflect the waves. So the curved seawall is an innovation from the flat vertical seawall. It breaks and disperses the energy and repel the waves back to the sea. It prevents the wave from overtopping, meaning that the wave will not go beyond the height of the wall itself. Okay, so if we use a flat wall, if there's a huge wave coming in, the seawater might go beyond the height of the wall. But this is unlikely to happen for a curved seawall, meaning that if the wave is coming in, it hits this curved wall and it will be sent back to the sea, okay, by a somewhat circular motion. Okay, so this is an example of a curved seawall. And yeah, the bottom one is even being combined, okay, with a step seawall. But the step seawall should be enough for smaller surge of water. But when the surge becomes a lot higher, it can be handled by the curved seawall. Okay? So you know, right, when there is a hurricane from the sea coming in, it does not only bring in a lot of wind, okay? It will also, due to the suction, it will increase the sea level. That is known as the surge. Okay, so especially in the America where they have a lot of tornado season and things like that, when a hurricane comes in, normally they will experience like memang banjir lah. Okay, these are not normal water. These are sea water coming inland because of the surge. That is before the hurricane comes in. Okay, advantages, course, being mentioned here. The waves can't overtop the wall. It redirects most of the energy. So this will result in a lot less pressure towards the wall itself, yeah? Because it's curved. It's not just impacting the flat wall. So this type of curved wall will last a lot longer. In terms of design, it's more complex to build. Okay, you have all these shapes, and then the waves can scour the material. Kalau kita tengok the first picture ni, bahagian bawah dinding ni, dia macam kasar sikit. This is because of the energy from the waves. Okay, daripada bahagian bawah ni nak dipusingkan ke bahagian atas, the sea water starts to eat into the concrete. Okay, so dia jadi macam menggerutu kat bawah. Next, we have the mount type. Okay, so this is an example mount, or known as revetment, used in less demanding setting where a lower energy erosional processes operate, where you do not have such high energy waves coming into that area. So the least exposed site involved the lowest cost bulkhead and revetment of sandbag or geotextile. So by using a mount type, we can reduce the cost. These sandbags or stones act as an armor to protect the shore and minimize erosion, whether it is watertight or it is porous. Allows water to filter through after the wave energy has been dispersed. So, as you can see here, this is a mound. and it uses a lot of rocks. Advantages: use porous design of rock or concrete armor. Slope and loose material ensure maximum dissipation of energy because again there's a lot of void between those rocks. Okay, so it helps to reduce the energy of the waves before it's being ejected out. And of course, lower costs. You do not have to, you know, pay in terms of very expensive material, design, construction, things like that. Disadvantages: less durable. So that's why it can only be used in area where the energy waves are a bit low. Shorter life expectancy, meaning that it needs to be, you know, to be maintained. Okay, periodically, okay, we maintain any stones or boulders that have been taken out needs to be replaced. It cannot withstand or protect from high energy condition. Tak boleh lah sebab high waves will cause the stone itself to be taken out, okay, over time. So next is the construction of sea walls. Okay. So site investigation as usual, including the observation of high tide, low tide. All the tidal information needs to be acquired and to be analyzed. Not just daily high and low tide, meaning that the highest tide in 100 years needs to be observed. And because sometimes during hurricane season, things like that, the tide will go higher than normal. So that has to be uh, taken into consideration. Preliminary work, okay, and then dredging, okay, for seawall foundation. This is very important because the solid bedrock at the shoreline needs to be accessed to build a strong wall. Okay? If that wall is not being properly anchored to the bedrock, I mean, in a couple of years saja, you punya wall pun habis tanggal lah. Okay? So the bedrock is very important. Then depositing rock fill for rubble mound foundation. Okay, start building the foundation. If it is a rock fill lah, kan? Kalau the seawall is made out of concrete, and then they akan start with the formwork, rebar, concrete. Biasalah tu. And then installing precast seawall block. This is if you use a precast concrete technology lah kan. You just have to prepare the foundation of the wall and then just bring in the precast concrete seawall panel. More examples. Maintenance. So typically, seawall have low maintenance as long as it is being built according to specification. You do not build it according to specification, it will become very expensive to maintain. You have to have weep holes. Lubang biasalah kalau kita buat dinding dekat tanah ke apa, mesti ada lubang tu. Supaya air bawah tanah boleh keluar. Kan? So need to have weep holes. And then scouring. Tip of the wall if there is no toe protection. Toe tu maksudnya bahagian dasar uh, dinding tu dia punya tapak dinding tu perlu dilindungi dari hakisan. Kalau tidak your wall can just tumbang just like that. Wave energy deflects down the wall. Ombak tu kan, ombak yang kena pada bahagian dinding tu, dia bukan bahagian tu saja. Dia punya wave tu akan travel along the length of the seawall. That needs to be taken into consideration. And of course, debris. Okay? Because yang menghentam dinding tu bukan setakat air saja. Okay, sometimes huge chunk of boulders, okay, dan sebagainya yang boleh merosakkan dinding. Alright, that is just on seawall lah, baru seawall. We take a 10-minute break. Okay, before we continue. Okay, thank you everybody. Next, we move on, okay, to groins. Okay, groins, they are perpendicular to the shore, extending from the upper foreshore beach into the water. So, if we have the wall, the sea wall is as long as the beach goes. Okay, it's in it's in the same orientation as the shore itself. The groins is actually perpendicular. It is 90 degrees compared to the shore. Okay, if you can see, okay, the design is like this. So you may have the sea wall across the shore, but groins is 90 degrees to the shore. So it is moving towards the sea. Okay, so we can have the groins like part of it is above water and some part of it is below water. And sometimes the entire part of the groins are underwater. So dia nampak pelik sikit. Okay. So all of a groin may be underwater, which is in case it is a submerged groin. Groins are made out of material dia macam-macam. Wood, concrete, rock pile, sandbags, anything. Gabion. So they are used together with seawall. So the seawall is along the coastline. The groins is 90 degrees compared to the coastline. However, it may cause a shoreline to be perceived as unnatural. So rupa dia kurang cantik lah. Okay, so this is groins for a river. So you can see that the shoreline become a bit macam staggered. Kan? Dia macam jadi zigzag macam tu. So that is what it meant by shoreline ni dia akan jadi rupa dia kurang natural. Dia tak lurus. Okay, because of the groins. So the groin creates and maintains wide area of beach or sediment on its uprift side. Reduce the erosion on the other. So basically, function here is almost the same as a sea wall. Is to protect the shore from erosion. It is a physical barrier to stop sediment transport in direction of the longshore transport. So, perkara yang mempengaruhi hakisan tu ialah the groins length and elevation and spacing between the groins tu berapa jarak. Okay. So these are determined according to the local wave energy and beach slope. So these are all to be calculated before the groins are being built. So if the groins are too long or too high, it will accelerate downdrift erosion because they trap too much sediment. And if you can see that the groins will cause a lot of sediment to be trapped between these groins. Kan? So hakisan tu kurang berlaku lah. Yeah. If the grounds are too short, too low, too permeable, are ineffective. So this is the motion of the waves. Okay, the sea waves that come in, rarely it is like 90 degrees towards the beach, okay, towards the shore. Dia mesti ada curvature tu. Okay, so that's why we need to put the groins there. The groins will function just like a seawall. Okay, so this is how the groins will entrap sediment, okay, uh, to its base. So if you see this black line as the coast where the water meets the sea, ni pandangan atas, top view. So this is the beach, and then you put in 1, 2, 3 groins here, and the source of the wave is from here. Kan? Average wave alignment. Okay, kalau wave tu datang dari sini, okay, dia akan travel, dia akan hit this first groin, okay, and then segala pasir-pasir yang dibawa oleh ombak tu akan sangkut di sini. And then wave yang terlepas daripada groin yang pertama ni, dia akan pergi kepada groin yang kedua. Kan? So sediment pun sangkut kat sini. And the next. And the next. Tapi masalahnya bahagian sini akan ada sedikit hakisan yang merah tu lah. Okay, lagi jauh dia daripada sumber ombak tu ataupun wave tu, lagi banyak hakisan ke bahagian dalam ni. Okay. So tu yang dia katakan dia punya beach tu takkan, rupa dia takkan cantik lah. Okay, groins do not add extra meter to the beach, but mainly retain some of the existing sediment. Okay. So some of the material, rocks, bamboo, timber, solid or rock armor. Okay. Submerged or non-submerged. So these are some of the materials that can be used. Whatever goes lah. That is very flexible. Okay. Boleh guna piling, sheet pile, H pile, with timber legging, timber pile, fabric bags, sand bags, gabion, batu besar pun boleh. So this is a warning sign for submerged groin. Okay, you can see that they are using timber. They are using piling, and some of the groin is already in the water. Yang ini menggunakan timber. Obviously, it won't last that long, okay, compared to rocks, compared to this lah, especially. So this is the concrete core with rock armor. Okay. So yang ini memang tahan lama lah. And you can see what it is protecting kan. Kat belakang tu macam ada penempatan orang kan. A good thing about this, dia tidak menghalang laluan groins ni kan. Compared to if you put a seawall here, okay, orang nak bergerak ke kawasan pantai pun susah. Right? Animals dan sebagainya. So, menggunakan groins ni, dia tidak menghalang. Okay? Especially kalau design macam ni, lagi orang suka lah kan. Boleh mancing. So, it serves attracting groin point downstream. Or serve to attract the stream flow. Okay. Ini macam mana groins tu kalau dia dipasang pada sungai. So, sama ada groins tu dia mengikut arah air pasang ataupun arah air surut ataupun dia just tegak. Okay. Kalau pantai tu tak kisah. Kita dah pasang tegak je lah kan. Kalau sungai ni dia lain sikit. So you point downstream, point the entire length of the groins, point it towards downstream. It serves to attract the stream flow toward themselves and do not repel the flow toward the opposite bank. So by having it pointing downstream, it maintain deep current close to the bank, deflecting, change the direction of flow without repelling. And then repelling is for groins which are pointing upstream ke arah air pasang. And groins can also be classified by shape. T-head, L-head, hockey stick, macam-macam design. Ni contoh dia lah. Kan? So ni semua yang A dan B tu kira pandangan atas lah kan. A tu sama ada groins tu dipasang hanya pada kawasan yang mengalami air pasang surut ataupun kita panjangkan lagi sehingga ke laut. So berapa panjang groin yang kita nak pasang tu. And then these are some of the intricate design. L-shape, T-shape boleh protect from waves a bit better. Yang ni ialah C ialah pandangan sisi dia. Sama ada menegak, untuk trapezium dan sebagainya. And then this is another design, zigzag. Groin. So the bentuk zigzag ni as if the groin is that big lah kan. But we are using less material. Okay. So bayangkan cost kalau nak buat groin sebesar ni menggunakan konkrit dan sebagainya, tentu cost dia akan menelan belanja sangat tinggi. So the solution is by using the zigzag design. Okay. So the effect is almost the same. So kat sini kita nampak timber groins. Kalau tengok dia punya pantai tu jadi berlekuk-lekuk kan, kat sini dia lekuk between the groins tu dia akan satu curve kat situ kan. Okay, so this is concrete groin. Okay, obviously certain part has a lot more sediment than the others. And tetrapod. Okay, tetrapod groins. So they just lambak kan. Tak kisahlah tetrapod ke rock, boulders ke kan. Towards the sea. And so they become a groin. And this tetrapod will help a lot in terms of reducing the magnitude of the waves. Kan kalau tengok sini banyak ruang kosong antara tetrapod ni. Dia akan suck in the wave and then slowly reducing its power kan. Sebab dia dah sangkut kat dalam lubang-lubang tu. So groin. Okay, so dia buat groins along the jetty. This can also help protect the jetty. Okay, so that is normal tetrapod. Being built out of stone. First of all, excavation. And then backfill with a layer of stone. And then, of course, we put the stone boulders on top of that layer. So it's important that layer of solid ground be accessed. Kalau tidak, punya ground tu letak batu yang besar-besar tu bukan ringan-ringan ni, dia akan mendap ke dalam tanah. We do not want that. Next is walkaway groins. Ni yang groins yang jenis orang boleh lalu atas dia. So they are independent structure consisting of concrete beams spanning pile driven along the length of the groin. So kita ada pile cap, okay, ada precast concrete untuk menyediakan dia punya decking lah. So the head of the groin is being built to its full height and then piles are driven into position through the void. So dia punya walkway ni betul-betul atas groin tu. Kan? So once you dah siap buat groin tu to its expected height, then dia akan drive pile untuk buat laluan pejalan kaki lah. The whole operation is able to retreat off the ground, leaving the near completed structure. Yang lain tu adalah pembinaan ramp, platform, sama ada in situ ataupun dia dah ada precast concrete section untuk walkway, laluan pejalan kaki. Okay, the third type, breakwater. Dapat. So macam mana rupa breakwater? Breakwater is like this. Or this. Structures constructed on coast as part of coastal defense to protect and encourage from effects of the both weather and longshore drift. Reduce the intensity of wave action. So this breakwater is more suitable for areas which have intense ocean wave. Okay. Kawasan tu dia punya ombak dari especially biasanya laut lepas lah. Ombak dia sangat kuat. This is the first layer of defense. You will meet that very strong wave of water head on. Yang first kali. So it will reduce the intensity of the wave in inshore water and by reduce coastal erosion and provide safe harbourage. Kalau kita tengok tempat kapal berlabuh, dia kalau tak ada yang natural ni, dia akan buat breakwater keliling teluk tu and then ada satu laluan saja untuk kapal tu keluar masuk. So rock ke ataupun konkrit yang digunakan akan keliling teluk tu. Breakwater can also be small structures to protect the beach. Okay. Ini biasanya untuk protect tempat kapal berlabuh macam tu lah. Yang ini untuk protect the beach. So the types. Caisson breakwater have vertical side that are usually erected where desirable to berth one or more vessel. There is a mass of caisson and the field within to resist overturning forces. Relatively expensive to construct in shallow water. Rupa dia macam ni. So it is a concrete frame, concrete caisson frame. Bahagian yang menghadap laut tu dia akan letak rocks, okay, ataupun tetrapod ke whatever lah to protect the base of the caisson from erosion. So di bahagian belakang tu tak adalah dia letak armor besar-besar macam tu kan. Okay. Sebab yang penting ialah bahagian yang menghadap ombak, menghadap laut. So this one is a typical rock near breakwater. Yang ini modern sikit. Guna tetrapod and a concrete wall. And then we have rubble mound breakwater. Rock or concrete armor units on the outside structure absorb the energy while gravel sand prevent the wave energy continuing to the core. So breakwater usually constructed some distance from the coast. So dia jauh daripada pantai. So it's either fixed or floating type. Ada floating type lagi. And then design is influenced by angle of wave, approach, and other parameters. So these are some of the design of rubble mount breakwater. So kita ada fine core and then kita ada rock. Ni batu-batu besar lah. So bahagian yang tak berapa besar tu biasanya di bahagian core. Sand, okay, this is the core or soil. And then more armor protection lah. Sampailah ke boulders. Boulders ni batu-batu yang besar. So example of a breakwater construction. So the operator tu memang kena seorang yang berkemahiran tinggi lah kan. Nak handle machine tu, nak gerakkan batu seketul-seketul. Okay. It's not easy. This is another type of breakwater. Ini modern sikit. Still banyak yang menggunakan hydraulic excavator lah compared to yang menggunakan kabel tu kan. Sebab dia lebih precise and a lot more powerful. Consequences. So because the coming wave hit breakwater, their erosive power is concentrated on the structure. This create an area of slap water. Okay, so bahagian belakang breakwater tu sepatutnya kawasan air yang agak tenang lah kan, compared to bahagian hadapan dia. Sediment can occur. Okay. So mendapan lumpur, selut dan sebagainya boleh berlaku di kawasan antara breakwater dan pantai, kawasan air yang tenang ni lah kan. Sebab tak ada ombak lagi dah. They can also prevent nearby unprotected section of the beaches from receiving fresh supplies of sediment. So kita menghalang ombak daripada masuk ke kawasan pantai, kita juga menghalang air yang fresh, fresh water, air laut yang fresh lah, yang penuh dengan oksigen. Kita menghalang sedimen yang fresh daripada laut masuk ke kawasan pantai. Okay. So dia boleh menjadikan kawasan yang dia protect tu macam kurang healthy lah. On the other hand, breakwater can also encourage erosion of beach deposit from their base, thus increase longshore. So seperti biasalah kalau breakwater ni tak dilindungi with all those rock armor dan sebagainya, there can be erosion. Another example. Yang ni lagi clear lah kan. You can see besar ni. Okay, breakwater ni. So they cover this area. Di sini ada dua opening di mana bot-bot ataupun kapal kecil boleh masuk dan dia boleh berlabuh di dalam kawasan ni. And obviously in this area dia punya ombak tu taklah sekuat ombak yang berada di luar breakwater. Okay. So sesuai lah untuk bot berlabuh. Next, gabion. Baru saya sebut gabion tadi kan. Tahulah kan gabion macam ni kan. Inilah. Batu-batu yang dia sumbat dalam sangkar. Empat segi. Itu gabion. Very useful. Dia ada cage, cylinder or box filled with rock, concrete and whatever else. For erosion control. Kegunaan gabion ni macam-macam. Bukan setakat erosion control kat pantai je. Sometimes nak buat retaining wall pun boleh menggunakan gabion. Even used in military. A sand-filled gabion used to protect artillery crews from enemy fire. Okay. Dia very useful sebab gabion ni dia mudah untuk dikendalikan. From one place to another. And if you want to build a temporary structure pun senang. Ya. Macam ni. First, mana ni? Okay. Ini ialah macam retaining wall lah. Kan? Ni diguna kat pantai. Ni sangka dia. Patutnya guna sementara je. Tapi tak tahulah kan. Sebab sangka ni lama kelamaan dia boleh berkarat. So kegunaan dia stabilize shoreline, steam back, slope, retaining wall, plot for seep filtration. Untuk menapis keladak. Sebab dalam gabion ni, antara batu-batu tu dia ada ruang kosong. So kalau kita gunakan dia sebagai retaining wall, dia tak memerlukan weep hole. Kalau kita gunakan dia sebagai filtration media, dia boleh block lumpur ataupun keladak daripada mengalir ke bawah. Filtration, okay. Force of flow of flood water. So gabion ni pun dia berat. Kita boleh susun dia banyak-banyak untuk redirect flow of water. Gabion basket has advantages sebab dia modular, kita boleh susun dia. Okay, sebab sangka dia standardnya ukuran. Sebab dia semua dalam satu sangka tu bekas, dia berat. Arus air tu susah nak wash them away. Okay? Berbanding kalau kita menggunakan batu seketul-seketul. And then they need a strong wire cage. Protect coastline. Made out of natural material. Very cheap to make. Kan? Just dawai dan batu. Disadvantage, lot of space. So when the rock and stone all erode, the whole cage need to be taken away. Saya rasa sangka tu lagi cepat rosak daripada batu kat dalam tu. Next is revetment, rubble mound, interlocking concrete, and gabion. Oh, okay. Sloping structures placed on banks or cliffs such a way to absorb energy of incoming water. Made as sloping structure. As permeable structure using stone, concrete. So dia macam seawall tadi. Cuma seawall is 90 degrees. Dia at an angle. So it can be permeable. It can be interlocked. Net mesh stone fill mattresses. Okay. So you can see here that the revetment is being used to protect this part of the slope of the cliff. Sebab kalau air terus menghempas bahagian cerun di bawah ni, this entire top part will start to fall down. Okay. So dia buat filling kat situ and then protect that fill dengan stone. Okay, rubble mound. Ini pun sama, dia fill this part and then protect it with interlocking concrete. Yang ini lagi penting ni dike. Tahu dike? Dike ni macam ampangan kecil yang dia buat. Apa bahasa Melayu dia? So biasanya dike ni orang buat sebab kawasan di belakang ni selalu dibanjiri air. Bila time banjir kan. Orang buat macam dike lah kat sini. Macam ampangan kecil. So biasanya buat daripada tanah, daripada batu kan. So dia nak protect permukaan dike ni daripada air. So dia pasang revetment lah ni. Revetment ni daripada gabion tadi. So material juga boleh gunakan fabric bag, mattresses, tube. Ni contoh lagi. Dia macam slope protection lah. So banyak layer kat sini. Geotextile layer, under layer of small stone. And then baru dia letak armor layer stone. So revetment will fix the location of the coastline but will not arrest the ongoing erosion. So it is permeable. Permeable maksudnya boleh ditembusi air lah. Sloping will not accelerate erosion. Dia memperlahankanlah kadar hakisan. So ni contoh. Ni memang selalu kita nampak kan. Kawasan tasik ke apa kan, dia longgok batu kat tepi ni. Okay. Nak panggil seawall bukan seawall. Okay. It's just a revetment protection. Okay. Kau tengok pun cost dia rendah lah kan. Okay, some other example. Ini menggunakan batu. Yang ini, revetment ni menggunakan interlocking concrete bricks. Yang ini lebih biasa kita nampak lah kat Malaysia. Kan? Malaysia jarang lah orang nak buat seawall apa semua tu kan. Sebab ombak yang berlaku kat Malaysia ni tak adalah sekuat di negara-negara yang basically menghadap Laut Atlantik lah. Okay? The North Sea. Yang ini biasa kita nampak kat Malaysia. Yang ini tak, ini memang tak pernah lah. Okay? Timber revetment. Buat daripada timber. Okay? Baik, ni contoh-contoh case study lah. As we know, keluar report kat Malaysia 2050 tenggelam. Okay? Worst case scenario. So kita memerlukan lebih banyak projek-projek untuk melindungi kawasan pantai kita. So ni tembok hakisan laut kat Melaka, tempat Melaka. Okay. So kat sini, ini apa ni? Classification dia. Adakah seawall? Adakah apa ni? Dari segi teknikalnya, this is a revetment. Kan? Kalau bahasa Melayu tu semua panggil tembok. Panggil tembok hakisan. Kan? Tapi dari segi teknikal ni, apa sebenarnya? So, that's why kita belajar konsep. Kan? Okay. So, this is just a revetment. Yang ini ialah lapisan batu di bahagian dalam, dia punya core. Yang besar-besar ni, kemudian itulah dia letak dia punya armor. Okay, ni contoh lain, kucing. Revetment juga. Kan? Rock revetment. Habislah pasir. Kan? Jadi batu lah. Okay. They build core dulu kat atas pasir tu, lepas tu dia letak rock armor. Cost dia lebih efektif lah. Basaltic revetment, okay, batu-batu ni. And flex slab. Okay. These are interlocking tile. Interlocking concrete. Okay. So dia susun, dia lekat to each other macam orang main Lego lah. Interlocking. And south revetment. Revetment ni dia lain sikit sebab dia ada macam protrusion ke situ. Macam ada tiang pendek situ. Okay, this is to break up the ocean wave. Okay. So mungkin kawasan tu dia punya ombak dia kuat. Instead of putting more armor, dia letak this extension protrusion untuk melemahkan ombak tu. And lastly, beach nourishment. So this is a part of a larger coastal defense scheme. It's an ongoing process. Dia takkan siap macam tu saja. Dia akan perlu dibuat secara berkala. It does not remove the physical forces that cause erosion. Hanya mengurangkan kesan dia. So dia tidak menyelesaikan masalah erosion tu. It's just segala kerosakan yang berlaku tu dia akan perbaiki. Itu saja. Okay. So it's popular because it preserve the beach resources and avoided the negative effect of hard structure. Macam kat case study tadi itulah kan. Daripada pasir, pantai, best-best jadi batu kan. Siapa nak duduk kat situ kan. So yang ini lebih popular lah. Especially di kawasan-kawasan yang ada industri pelancongan yang agak signifikan lah. Okay. Orang sana, pergi sana nak mandi pantai nak pasir apa semua. So kalau diganti dengan batu, siapa nak datang kan. Okay. So dia keluar modal lah sikit untuk memperbaiki kesan akibat hakisan. So it preserve the beach resource and avoid the negative effect of half structure. Okay. Dan sebagai untuk memastikan kerja-kerja perbaikan tu tak terlalu kerap, biasanya dia akan melebarkan lagi kawasan pantai tu. Dia tambah lagi dengan pasir. Okay. So this is an example beach nourishment. Dia tambah lagi kawasan pantai inwards, maksudnya ke laut. So known as beach replenishment or sand replenishment. It's an artificial process. Dia bukan proses yang natural. Jadi kita gunakan mesin pasir yang dibawa dari tempat lain untuk tambah lagi pasir yang sedia ada. To provide buffer for coastal erosion, sand lost through a long shore drift and erosion is replaced by additional sand. Yalah. Kadang-kadang kat kawasan ni kan berlaku hurricane dan sebagainya, taufan yang besar-besar tu, pantai tu daripada besar jadi kecil. Okay? Sebab semua pasir-pasir tu telah dibawa keluar. So they have to ganti balik pasir tu. So a wider beach can reduce a storm damage. So this is how they do it. Okay? So they build a fortification kat sini. And then baru dia akan backfill dengan pasir. Okay, so ni contoh lah. Proses yang sama. Mesin yang digunakan sama lah dengan mesin-mesin tadi. Mesin excavator, dump truck. Kadang dump truck tak cukup. Kalau bawa pasir banyak ni, dia bawa barge. Ataupun dia pump pasir tu dari kawasan lain kat pantai tu, dia pumpkan ke sini. So, mana pergi? Construction sequence. Sand dredger. Okay, dia korek pasir dari dasar laut. Ni dia punya contoh lah. Kat bawah kapal ni ada suction hose. Dia akan sedut pasir daripada kawasan ni. Ni dia punya workflow lah. Dredger pump sand from sea. Dia sedut pasir daripada laut lepas ni. Dan dia akan pump through this pipe. And then from here, dia akan hose dia sampai ke sini. Dan kat situ dia akan tembak pasir lah. Okay. Dia macam proses melombong pasir. Macam tu lah. Okay. Proses dia hampir sama. So kalau menggunakan kaedah pump, menggunakan kaedah pipe tu, dia lebih menjimatkan. Berbanding dengan guna kaedah korek dan angkut. Lebih jimat dan dia boleh handle lebih banyak pasir. Okay, so this is the hose. Okay, hose ni memang under high pressure lah. Kan, siapa pernah kalau pergi site tengok concrete hose concrete yang dia pump ke tingkat atas bangunan tu. Tengok hose tu macam very thick. Kalau dia pump tu nampak hose tu macam nak mengembang. You tahu dalam tu pressure sangat tinggi. So same goes here. Bukan sikit-sikit pasir yang dia orang pump eh. Advantages and disadvantages. Improve beach quality, improve storm protection, aesthetic value pun bagus. Kan? Tak ada Mak Saleh nak berjemur atas batu lah. Okay? Dia nak pasir. Okay? Disadvantage, expensive. Operation ni mahal. Kan? Mana ada construction murah-murah. Okay? Effect marine ecosystem. You pump keluar pasir daripada one place and dump it to the other place, obviously akan mempengaruhi kehidupan marine. And require continuous sand supply. Sebaik-baiknya pasir yang dari kawasan tu jugalah. Kan? Kadang tu pasir yang telah dibawa oleh hurricane tu ke laut. Kan? Hurricane tu bawa pasir ke laut. Orang ambil balik pasir laut tu letak kat pantai. Kan? Itulah kerjanya. Okay, so this is an example before and after kan. Kalau before tu tak sikit je pasir yang tinggal. Right? So after sand nourishment, so pantai dia bertambah besar. So benda ni nampak macam natural lah kan. Cuma kena buat berulang kali lah kan. Next year punya hurricane season, kondol balik. Lepas tu pump balik lah. Okay. And then this is Pantai Morib. Saya pun dah tak tahu Pantai Morib ni macam mana rupa dah. Lama tak pergi. Okay, so Pantai Morib, Banting, not the best of pantai if I could remember from my childhood. Okay. These days tak tahu lah kan. Kalau nak pergi mandi pantai tu jalan jauh. Jauh tu baru jumpa air laut kan. Sekarang tak tahu lah. Okay, so kat Malaysia ni guna teknik yang basic lah kan. Guna excavator dengan dump truck. So they are transporting sand to the beach. Okay, after nourishment, tak tahulah, boleh lah kot. Okay. Tahan ni morib ke tidak? Okay. So some photos here. Okay, another sand beach nourishment. Okay. Menggunakan kaedah inilah dump truck, excavator, bulldozer. Okay,